Today we'll learn how to graph rational functions. This is part one, so we'll be doing an easier rational function. The one we'll be doing today is f of x equals x plus 6 over x minus 2. In our first two steps, it won't really apply to this function because it's a very simple one. Notice step one says fully factor the numerator and denominator of the function, but these are already factored. And then it says cancel like factors from the numerator and denominator, and we're not going to do that now either. That'll come in another part. Our next step will be to, using the reduced or simplified function, which is what we have, find the vertical asymptotes. And we have learned that in order to find the vertical asymptote, we simply find when the denominator is going to be equal to 0. So in this case, we'll say x minus 2, which is our denominator, equal to 0, and naturally we get x equals 2. X equal 2 will be our vertical asymptote. So now we find our vertical asymptotes, and we remember that when the degree of the numerator and the degree of the denominator are the same, then the equation of the horizontal asymptote will be the y equals the leading coefficient over the numerator over the leading coefficient of the denominator. So in this case, we notice that our degree of the numerator is 1 and the degree of the denominator is 1. Therefore, our equation of the horizontal asymptote will be y equal to, and notice that the leading coefficient of our first term is 1 in the numerator, and it's 1 in the denominator. And so we get y equals 1 over 1, and that's going to be equal to 1. And that is our equation of our horizontal asymptote. Y equals 1 is our horizontal asymptote. Our next step is to find the x and y intercepts. So let's start with the x-intercept. In order to find the x-intercept, that's when y is equal to 0. So we simply say 0 is equal to x plus 6 over x minus 2. And if we multiply both sides through by x minus 2, and we cancel here, and we get 0 on the left side, we get 0 is equal to x plus 6, which means x is equal to negative 6, and that is our x-intercept. So x equals negative 6 is our x-intercept. And now we want to find the y-intercept. And if we remember, the y-intercept is simply when x is 0. So if we want to substitute 0 into our equation, we'll get that as follows. Let's draw a little line here so we can separate the two. And if we say 0 plus 6 over 0 minus 2, that'll be our x-intercept. So we finally get y is equal to 6 over negative 2, and therefore y is equal to negative 3. And therefore our y-intercept is at negative 3. It turns out that a graph can actually cross the horizontal asymptote at certain points, and so we need to check if that will happen. In order to check to see if the graph will cross the horizontal asymptote, we have to set the reduced function equal to the horizontal asymptote and solve. And let's do that, and then we'll explain the rest. So our function is x plus 6 over x minus 2. Our horizontal asymptote was 1, so we set this equal to 1. If we multiply both sides through, multiply both sides by x minus 2, we will get these two canceling, and we get x plus 6 equals x minus 2. And if you notice, when we solve this, you subtract x from both sides, and you get 6 equals negative 2. Well, that's obviously not true. Since that is not true, it turns out that the graph does not cross the horizontal asymptote. If we did get something that was true, if there was a solution, then the graph would cross the horizontal asymptote. We'll see another example of this in another part. Our next step is to connect the known points by following asymptotic behavior, or very simply, just create a little table and just plot a bunch of points so you can see the way your graph will look. And then we'll check that. However, what's important here is we test the x values in each interval created by the vertical asymptotes, because we want to know if the function is positive or negative depending on which section it's in. And this will tell you if your graph is above or below the x-axis as it nears the vertical asymptote. So what we have here is I've created a little table. We have our function x plus 6 over x minus 2. We could write that a little bit bigger over here. F of x equals x plus 6 over x minus 2. And before we do anything, before we even plot that, we probably want to draw our vertical asymptote. So if you remember, our vertical asymptote we discovered was at x equal to 2. So what I'll simply do in red, I will draw that. And magically we make the vertical asymptote appear. We probably want to draw the horizontal asymptote as well. If you notice, that was at y equals 1. We discovered that up above. So let's magically make that one appear. And now we see the x and y asymptote. Our next thing we want to plot is where our intercepts are. And if you remember, the x-intercept was at negative 6, 0. So that's our x-intercept. And our y-intercept was at 0, negative 3. So we'll put that down there. Okay, I've now taken the liberty of plotting some of the points from our table. And you'll notice that I plotted negative 8, 1/5, which was here, negative 6, 0, which was actually our x-intercept, negative 4, negative 1/3, negative 2, negative 1, and finally 0, negative 3. You certainly see the shape of being a curve, and if you'll notice at 2 it's undefined because that is exactly where our y-intercept was. If you're not sure how I got these numbers, all I simply did was, for instance, for the first one, negative 8, I simply substituted into the function f of x equals x plus 6 over x minus 2, and then I reduced the fraction. So now if I sketch this in, it will look something like this. But notice how it's going to get closer and closer to the horizontal asymptote, but never get there. And down below, it'll get closer and closer to the line x equals 2, but also never get there. So now we see what the graph looks like on one side of the vertical asymptote. Let's look at how it appears on the other side, and we'll plot some of those points. So at x equals 4, y equals 5. So x equals 4, 1, 2, 3, 4, 5. At x equals 6, y is equal to 3. So we'll put it there. At x equals 8, y is equal to 7/3 or 2 1/3, which is something like that. And you can certainly see the behavior of this if I try to connect the dots. Of course, it goes on forever in that direction. You'll notice that it will get closer and closer to the line, to the asymptote y x equal 2, and that's the vertical asymptote, and it'll get closer and closer to the horizontal asymptote at y equal 1, but of course it'll never reach there. And that completes our graphing of this function. And the most important part here is to remember all the different steps. Remember that we need to find the vertical asymptote and the horizontal asymptote, the intercepts. You need to determine if it crosses the horizontal asymptote. You're going to have to plug in a bunch of points to determine the behavior of the function on each side of the vertical asymptote. And then you sketch it in and you're done. All right. Thank you. I hope you enjoyed this. And now it's your turn. So see if you can graph this rational function. My strong suggestion is that you rewind the screencast and try to solve this problem as I demonstrate how to do the various parts of a problem very similar to this on the screencast. Good luck, and see you again next time.